The Institute of High-Energy Physics belongs to Chinese academic sciences. The mother institute was established at 1950, called the Institute of Modern Physics. So in the 1973, became an independent institute for the particle physics and the accelerator technology. Now, the institute is the comprehensive and the largest fundamental research center in China in both the budget and the number of employees. We have about 1,500 employees, 500 PhD students, and about 60 postdoctors. So the annual budget is about 1.3 billion Chinese yuan, plus some construction money. The goal of the institute is an international center of the particle physics. Also, we doing the multiple disciplinary research center based on the large scientific research facility. I will give some details. So the major research field in our institute is the particle physics. We're working on the Charmoium physics, the Beijing Electron Particle Collider 2. 2 means upgrade. And we work at LHC International Corporations, CMS, and Atlas. And we have the BEPCII Cosmic Ray Observatory in the Tibet. And we also doing particle astrophysics, like the satellite experiment. This is the hard X-ray modulated telescope to be launched October this year. We have the largest team for the accelerated technology and applications for high luminosity E+, E- collider, Beijing Electron Particle Collider upgrade. Also, we're working for the high power proton accelerator for the spallation neutron source, also for the accelerated driving subcritical system. I will give one slide about that. For the radiation technology and applications, we're working with the synchronous radiation source and applications because the first China synchronous radiation was based on the BEPCII. So we open to users of the light source users 25 years ago. We have a large community of the light source users in China. And now we are building spallation neutron source in the Dongguan. And we also carrying the multiple disciplinary research, including the life science, nanoscience, energy, and the environment. So this is the Beijing Electron Particle Collider. So it was built in the 1980s. So 10 years ago, we made a major upgrade, convert the storage ring into the two-ring collider. You see, the tunnel was built in 1980. It's quite narrow. So with the one-ring collider, we only can have one bunch of the electron collide with one bunch of positron. So when we convert into the two-ring collide, then we could have 100 bunch electron collided with 100 bunch positrons. So the luminosity, which means the density of collision, could be increased by 2 orders of magnitude. So we succeed this upgrade, and we have many interesting results. One of interesting results is the discovery of the new particles called Z sub C. The mass is 3.9 GeV. So it's the charged Charmoium, because the Samtin and the Richter discovered Charmoium at 1974. So all of Charmoium is CC bar, 2 quark bound state. So it's the neutral particles. And at this time, we discovered a new particle with the four quarks. So that's very interesting. it was selected to the #1 highlight by UPS, by APS, American Physics Society, at the end of line 2013. So it was #1 results at that year.